Welcome to my new series on doing general linear models in JASP. In this video, we're going to cover the new way of doing statistics from t-tests to regressions to ANOVAs, but we're going to call them general linear models. Why? Well, that's kind of what this video is about. So let's move on. When you first took statistics, you probably were taught something like this.
If you have two or more predictors and all independent variables are numeric, we're going to do multiple regression. If they're categorical, we'll do
Blah, 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 blah. Are you ready to vomit yet? Because I am. And I do this for a living. Did you experience a shudder of fear?
I swear, statistics will be the death of me.
Well, guess what? You don't need that anymore.
Really?
And you have been unfairly treated, you poor soul. You have been taught a bunch of unnecessary distinctions, and it's not your fault you did terrible in statistics. Nor is it the fault of your stats teacher. It is the fault of textbook authors who haven't written anything better, until now. So let me just simplify statistics for you. In statistics, we want to predict something. The thing that we want to predict, we call the outcome variable. So maybe stress, anxiety, energy, test performance, these are things that we might want to predict. And to predict that variable, we see if there are other variables that are related to it. We call these our predictor variables. Maybe we want to predict somebody's stress, the outcome, based on the hours of sleep they had. That's our predictor. Or maybe we want to predict test performance, the outcome, based on how many hours they studied, which is our predictor. And sometimes the variables you want to use to make predictions are categorical variables. Like gender, maybe we want to use gender to predict test performance. Or maybe we want to predict anxiety based on who goes to therapy or not. Or maybe we want to predict somebody's stress based on whether they were randomly assigned to a treatment or a control group. Other times, the variables we use to make predictions aren't categories at all. Like when we wanted to predict test performance from how many hours they studied. Both of these variables are numeric. And here's the honest fact that all textbooks get wrong. It doesn't matter whether your predictor is categorical or numeric. And with that alone, we've eliminated half of our decision tree. But we can make things even easier. First thing is every statistic can be visualized with a graphic. Who likes looking at pretty pictures all day, huh?
Not those kind of pictures.
Here is a graphic that shows how many hours of sleep somebody gets and the amount of anxiety they have. We see that as you get more sleep, you tend to have less anxiety. And you see that line there? That's called a regression line. And the steepness of that line is indicated by the slope. Here's another graphic of stress and treatment group. Oops, there's a lot of overlap in our data points. So maybe we'll just shift the scores around a little bit. We call this jittering. There, that's better, isn't it? But look, it's still a scatter plot. And look, there's even a slope. Isn't that easy?
Boy, that was pretty clear, I think.
When you realize it's all the same thing, it's so much easier to figure out what you're doing. You're not having to learn completely new procedures for every test you want to do. No, we can't move through regression now. I just understood a t-test. In the GLM approach, it all builds on top of one another. So now, with that, let me show you in GLM terms all the things that you learned in undergraduate stats. A t-test. Example, depression is equal to treatment group, which is control versus treatment. Or in math-ese, depression is equal to B0 plus B1 times treatment. And there's our scatter plot. Easy peasy. ANOVA. Depression is equal to control versus treatment A versus treatment B. Or in math-ese, depression equals B0 plus B1 times treatment A plus B2 times treatment B. And look, here's another scatter plot. Correlation or regression. Depression is equal to anxiety. Or in math-ese, depression is equal to B0 plus B1 times anxiety. And look at that again, it's another scatter plot. Or maybe you're doing a chi-square. Are you on an antidepressant, yes or no? Equals, are you in therapy? Never, in the past, or previously. Or in math-ese, antidepressant equals B0 plus B1 times past plus B2 times previously. Although a chi-square is technically a little more complicated than that. We'd need to do generalized linear models, but we're not gonna get into that. Or maybe you're doing a related T. Difference in depression before versus after therapy is equal to B0. And look at that, here is our scatter plot. It's kind of funky looking. And we'll talk more about that later. By the way, in the description, there is a link to a PDF. And in all these images, we have graphics of a t-test and ANOVA, regression, all that jazz. And so in the next few videos, I am going to reteach you statistics in the way that you should have been taught. I'm gonna show you how to model a relationship between a categorical predictor and a numeric outcome. We would traditionally call these a t-test or an ANOVA. And I'm gonna show you how to visualize these. I'm gonna show you how to interpret and calculate important statistics, like the means or the mean differences or the standardized mean differences. And then we're gonna model numeric predictors. We call these a regression. And I'll show you how to visualize these and compute statistics for these as well, like a slope and an intercept and a correlation coefficient. So with that, let's review our learning objectives. Number 1, the two components of the GLM approach. All that is predictor and outcome. And sometimes you have multiple outcomes, but we'll get into that later. Be able to compare and contrast the old versus the new way of doing statistics. In the old way, we had a decision tree with very separate distinctions between each of these statistical procedures. In the new way, all we have to do is figure out what we're predicting and what we're using to predict it with. Outcome and predictor. Number 3, how to do scatter plots of categorical predictors. And again, we just take those scores and shuffle or jitter them. And then finally understand the visual way that we represent a t-test, an ANOVA, a regression, a chi-square, and a related t. So with that, peace out.
I like Star Wars.